All right, let's get started with section 6.2. So, in section 6.2, you've actually kind of done this before. Remember when we were working with the Pythagorean theorem and you had to take square roots of both sides to get rid of something squared? That's exactly what this is about. One of our other ways that we can solve quadratics, because there are lots of ways to solve quadratics, as you saw in 6.1, there's factoring. In 6.2, you're going to learn about square roots. In order to solve quadratics, you can use square roots. And in order for square roots to happen, the biggest thing that you have to make sure of is you must make sure that the squared part is by itself. The squared part is not by itself, then you got to fix it. Let's change that 2 to the square. So if you look in this squared piece is definitely by itself. It's ready to take a square root of both sides. Okay? And that's what 6.2 is all about. It's about using square roots. If we look at this guy, is that squared piece by itself? Absolutely. So this thing is ready to take a square root of both sides. And this one is the squared part by itself. Now, most of you probably said no because you see the +1 inside here. But this square is actually protecting everybody in the parenthesis. Everybody in the parenthesis is with this square. So is this square part by itself? Yes, because there's nothing outside of the square. Everybody in here is with the square. So this thing is actually ready to take a square root of both sides. What about this one? Yeah, it's just like what we did a second ago. This square part is by itself. It's ready to go. We're ready to take a square root of both sides. What about this one? Hopefully you said no, and we got to get that x squared by itself. And once we get it by itself, then we can take a square root of both sides. I think I have one more. Nope, that was it. So let's go through these and talk about how we're going to get these answers. Okay? So first things first, I'm going to need my calculator to come up. So let's open that. There we go. I think it's thinking about it. Maybe. But now I know it definitely is. All right, there we go. Now we're coming up. Because we're definitely going to want to look at our square root key in this. Okay. Now, in this as well, because we know about square roots and everything like that, you are going to need to break down radicals. They do not want decimal answers in this. Okay? So, since the squared part is by itself, we're ready to take a square root of both sides. So, we square root and we square root. And x is equal to, because the square root takes care of the square, they cancel each other out. Well, what's the square root of 64? And most of you would say, Mr. Armstrong, the answer is 8. And I will tell you that you are half correct. Whenever you take a square root, this is the most important thing. And I promise you, those of you that are moving on to college algebra, you're going to have to know this. Okay? Whenever you take a square root of both sides, there is one thing you have to put in front of your answer, and that is called plus or minus. And that's what I have written under here. It is very important that you do not forget plus and minus in front of the answer, because you are generating two numbers that work for it, a positive version and a negative version. Because if I go back and check this, which you do not have to check these, but I just want you to know that if I take and put 8 squared in, that does give me 64. And if I put a negative 8 and square it, that also gives me a positive 64, because any negative number squared is always positive. So that's why that plus or minus has to be there, because there are two answers to that square root there, a positive version and a negative version. Okay? Go ahead, pause the video, give this one a shot. Okay. So we already know that it's ready to take a square root. So we take a square root, and x is equal to, Hopefully you said plus or minus the square root of 24 and did not give me a decimal answer to this, because this doesn't come out nice and neat like what we had a second ago, which means that we need to use our skills that we learned in chapter 5. This thing can break down. Square root of 24, and again, I always do good child, bad child, is the square root of 4 and the square root of 6. What's the square root of 4? That's 2. And the square root of 6. So this part is going to replace the square root of 24. So our final answer really is plus or minus 2 square roots of 6. Okay? All right. So let's talk about this one. We know that the squared piece is by itself. So how do we get the square, or how do we get rid of the square? We square root it. So we end up with x plus 1, because the square takes out the square root, leaving you with what's underneath. And then over here, we'll have plus or minus 5. But we're not done solving. We got to get this x by itself. So how do I get rid of a plus 1? We subtract 1. And now many of you are going to want to tell me the answer is x plus or minus 4. And I'll be like, no, it is not that. What's really going on, remember, you have two versions of this plus or minus 5 here. So what's going on is you have negative 1 plus 5, and you have a negative 1 minus 5. Okay, there are two versions of this number. It's like we have two separate equations. One of them was x plus 1 equal to 5. The other one was x plus 1 equal to negative 5. So we actually have two separate answers here. So in the end, you do need to figure out these two answers separately. So what's negative 1 plus 5? That's 4. What's negative 1 minus 5? That's a negative 6. And those are your two answers. 4 and negative 6. Okay? Because this acts like it's two separate equations. If you want to write out the two equations, by all means, go right ahead. Or you can come down here and think of it as just negative 1 plus the 5 and negative 1 minus the 5. It's all the same. All right. Pause the video. Give this one a shot. Okay. How do we get rid of something squared? Square root both sides. So 4x plus 7 equals plus or minus the square root of 3. Now this doesn't work out nice and neat like what we had a second ago. Okay, so let's start taking a look at what's going on. So let's get this x by itself, and then we'll talk about that final answer. How to get rid of a plus 7? Minus 7. And that gives us 4x equal to negative 7 plus or minus the square root of 3. Because remember, these two things cannot get together. Okay? So I'm just going to keep the plus or minus between them. All right? And then how do I get rid of multiplication here? Divide by 4. Divide by 4. So this right here represents our answer. All we need to do is just make sure that it's fully reduced. So just like what we had when we rationalized the denominator back in, I believe that was 5.4, check your square root. Can our square root break down? No. Square root of 3 is here to stay. And then you check your numbers out front. Remember that there's like a number 1 right here. Is there a number that can divide both 7, 1, and 4 other than 1? No. So this answer is good the way it is. Now what they'll want you to do in your assignments, they'll want you to actually separate it out into its two answers. So one of the answers will be negative 7 plus 1 squared root of 3. Or you just put the square root of 3 because we know that there's a 1 in front. All over 4. The other answer will be negative 7 minus the square root of 3. all over 4. Okay? They do want you to separate those answers out. And just so you know, usually the one that has the minus is the smallest answer out of the two. Sometimes it kind of flip-flops depending on what's happening. But so if you're trying to decide which one is the smaller of the two answers, the one with the minus in it is usually the smaller of the two answers. And there we go. That's as hard as what this gets right here. Okay? So in the end, once you get rid of the addition and subtraction and the multiplication division, in the end, you check it just like what we did when we rationalized. Simplify your radical and then take care of your numbers in front. All right. Pause the video, give this one a shot, and that will conclude 6.2. Okay. So we got to get the x squared by itself. This was the only problem where I didn't have it by itself. So we got to move everything first. So we got to subtract 7. That will give me 5x squared equal to, I believe that is 245. Okay. And then we're going to divide by 5 because we still got to get that x squared by itself. It's not by itself. X squared is equal to, well, 245 divided by 5. I don't do that in my head. 245 divided by 5 gives us 49. And now that the x squared is by itself, how do I get rid of something squared? Square root both sides. And x is equal to, hopefully you said, plus or minus 7. And that is how 6.2 works. Good luck.